To describe one universe like ours requires a vast amount of information. It requires specifying not only the physical laws, but also the position, direction, and speed of every particle in the universe. This is estimated to require on the order of 10 to the power of 90 bits. Yet to specify every possible universe of our kind, a multiverse of every possible arrangement of particles ruled by our laws of physics, needs much less information. Such a multiverse requires only the information to define the physical laws, particle types, fundamental forces and constants of nature. This can be done in just a few pages of equations. Describing our specific universe is like describing a specific book from the Library of Babel. It needs more information than the library itself. In theories such as the string theory landscape, the constants of nature are not specified by the theory, leading to an even greater multiverse consisting of every possible universe having every set of possible values for the constants of nature, for example different values for things like the electron mass, and the strength of electromagnetism. There are reasons to suspect this, or something like it is true. For one, it explains why laws of physics and constants of nature appear fine-tuned for the emergence of life. C. Was the universe made for life? This description of a string theory landscape needs less information. It might save a page by not having to include the 30-some-odd constants of nature. And yet, it describes a vastly larger multiverse. The observable universe with particle velocities, physical constants and physical equations requires 10 to the 90 bits or about 10 to the 85 pages to specify. The quantum multiverse with physical constants and physical equations requires approximately 144,000 bits or about 6 pages to specify. The string theory landscape with its physical equations requires approximately 120,000 bits or about 5 pages to specify. All physical possibility requires 0 bits. What happens when the length of reality's description goes to 0? This would leave the equations themselves unspecified, implying an even greater multiverse. This multiverse includes universes not just of every arrangement of matter, nor universes of every set of constants, but universes ruled by every kind of physical equations. Quote, if all possible string vacua, spacetime geometries, masses of elementary particles and interaction strengths, and laws and bylaws of physics are realized, then all possible descriptions are satisfied. This is equivalent to 0 information. End quote. David Pearce in Why Does Anything Exist? 1995. Thus, to specify all possible physical laws, all possible physical constants, for all possible universes, needs no information at all. Might we inhabit such a nothing? This is the thesis of Russell Standish's 2006 book Theory of Nothing. Standish believes our universe, with its seemingly vast quantity of information, is something like a book in the Library of Babel. We would then be denizens of nothing, occupying a place within a total reality which altogether amounts to 0 information. Such a reality, one of 0 information, is the simplest state of existence. It's simpler than an empty vacuum or a geometrical point, as these both need a non-zero amount of information to describe.